Okay, so we already went through the two other methods, the graphing method and the substitution method. This is the final method in this unit, 4.3, the elimination method. So you get to choose which method you like when solving these equations, because you can see all three methods will give you the same answer. We introduced you to this same question from 4.1 and 4.2. You should already know the answer to this is going to be 3, 1. But to show you how to do it without graphing, and the issue that we had with substitution is that we could get fractions at sometimes, this method we will avoid fractions and then we don't have to graph. So, just like I did with the others, we went with the steps. Now the steps, you can see it's maybe a little harder to follow because there's a lot more explaining on to do with these. So make sure that you do look at this while you're looking at the video. The first thing that you want to know is that you have to stack the like terms on top of each other. So we say that vertically. Basically, you want all the x's to line up in a column, all the y's to line up in a column, the equal sign to line up, and then the constants to line up. So sometimes you might have to tweak this problem, to rearrange it so that the x's, the y's, the equals, and the constants line up. So you're basically trying to get all the variables on one side and then the constant on the other side, the equal sign. If you look at the problem that we have up on the board, and if you looked at the other questions that we give you, luckily they're all lined up for you. But if they're ever not lined up, you know how to move things around. It's like solving for a specified variable. But notice the x's line up, the y's line up, and the equal sign and the constants line up vertically. The next thing that you're going to do is you're going to see if any terms get eliminated when combining like terms. You're using both equations, so you're going to work down the column to see if anything eliminates. If nothing eliminates, that's where it gets tricky. We have to do this transformation. By doing this transformation, A through D, then you will have like terms eliminate. Now you might have just one term that eliminates, or you might have two terms that eliminates. If only one term eliminates, then you solve for the variable and then you have 1/2 of the equation. Just kind of like how we had it with the substitution method, where when you solve the equation you get maybe x equals, you have to plug it in to get the y part. If both pieces eliminate, then you have to see if you have a false statement, then you know it's no solution, or a true statement, then that means you have infinite number of solutions. So let's take a look at this guy. And we already said step 1 is already perfect. See how the x's line up? See how the y's line up? There's your equal signs that line up, and then your constants. So once you know that it's already set up correctly, then what you're going to do is see if anything eliminates. So when you go down the column, notice that you have x, x. Remember, we're collecting. Okay, that's what I mean by combining. This is understood as 1x, 1x. You remember what happens when you have two positives? You add them. So you're going to get 2x here. But how about positive y and a negative y? Remember, this is understood as positive 1y. This is understood as negative 1y. So when you have a plus 1 and a negative 1, remember, subtract. They actually eliminate because 1 minus 1 is 0. The y's are gone. Now on this side, we have a positive 4 and a positive 2. Collect, combine. Two positives you add, you get 6. Notice one term eliminates. So we do not need to do this. If no terms eliminate, we had to change it by going through A through D. Luckily with us, since something eliminates, we can go right down to step 4 by looking at to see if one variable disappeared, which in our case it did, only the y's disappear, then what we want to do is solve, because that will give us the 1/2 of our answer. So if I divide both sides by 2, notice I get x equals 3. Remember, that's not our final answer. We said that if this solves, that means you only had one variable left over, this only gives you half of your answer. So remember, our answer will either be no solution, infinite number solution, or an ordered pair. So since we get x equals 3, that means we're going to get an ordered pair. You know that this stands for x, this spot stands for y. We know the x is 3. So we need to get the other half. And I said to get the other half, you need to plug in that 3 into one of the original equations. It's up to you which one you want to use. If you want to use this one or this one. We've been typically using the first one. So x plus y equals 4. Plug in that you know that x is 3. And then solve for y. Subtract 3 on both sides so that we get y equals 1. The variables on one side, the constants on the other. Now that we have the other half, there's our answer. Just like we got it with the graphing method and the substitution method we got with the elimination method. This was pretty easy because when you collect like terms, something did cancel out, leaving us with just x. When we solved for x, we got half of the solution. Plug into the original to get the other half.